Hi there. In this student try, we're going to look at force of gravity. So first things first, let's look at the problem so we have a better understanding of how we could tackle it. So to determine the force of gravitational attraction between the Earth and a 70.0 kilogram physics student if the student is standing at sea level, very essential at sea level, a distance of 6.38 times 10 to the 6 meters from Earth's center. The reason why I'm saying it's essential at sea level, because this distance right here is given to you on your formula sheet, as if the mass is also given to you for Earth. It's on your formula sheet. Even the constant you're going to be using. So the only new value is 70.0 kilograms. These other values need to be known because some problems you're going to have is not given these values. So I'm going to get you to stop the video. But before you stop the video, I'm going to show you the solution in the GRASP method. GRASP method is actually what the textbook uses also. So in the GRASP method, the G stands for given. So write down all the values that are given in this problem so far. R is what you're actually looking for, the required. A is the analysis, so you start off with the formula and substitute the values. S is the solution, so putting your answer in correct significant digits. And then P is a paraphrase, just writing out the problem, answering it in a sentence. So starting off with this problem, before I do, please stop the video so you can actually try and see if you come up with the same answer. Now you will realize that the given are the following values, M, and then subscript E, E representing the Earth, it gives you the quantity. M, S, the S I chose for the student, which is the volume. Uppercase G, just representing the universal gravitational constant. Keep in mind, negative 11. A lot of students forget that negative 11 part. And then R, just representing the distance. So this is the distance from both objects. One's the center of the Earth, and the other one is actually the student at sea level. So what is required? You're actually looking for force of gravitational attraction. Keep in mind this is a vector quantity, so make sure there's an arrow above that. So we are going to include a direction at the end of the problem. Now keep in mind the direction is dealing with this whole fact of going downwards to the center of the Earth. So in our analysis, we start off with the formula as I stated earlier. So our formula is going to be uppercase G, lowercase m, subscript E, lowercase m, subscript S, divide by R squared. A lot of students forget the dividing of the R squared, so make sure you square the value. It's a typical distractor that you like to use in diploma, so make sure you include that R squared bit. Second bit, we're going to actually substitute the values now. So when we substitute the values, we're going to multiply them. So in the multiplication of the capital G and the two masses, we're going to put brackets between them to just represent that we're multiplying it. So start off with our value here. There we go. Then we start out with the mass of the Earth, and then we'll finish off with the mass of the student. Then we're going to be realizing we have to divide all of this with the distance squared. So don't forget the distance between the center of the Earth to the actual student. Okay, I'm going to actually now put in the brackets to get a better understanding what we're multiplying in our calculators. You might have to do this in 2 steps if you don't have a smart enough calculator. If you do have a smart enough calculator, so then you need to include the brackets because those actually will help, especially those TI-84s, those scientific graphing calculators. So next things next, I like to cross out my units next. These two would make kilograms squared, and this is kilograms squared right here, and this is dividing it. So those can say goodbye. The meter is squared, so that's meter squared, and here's your meter squared. So one's on the bottom, one's on the top. Goodbye. So what is left over? Newtons. Well, exactly what we're looking for. Don't forget the direction. So when you type this in your calculator, You the multiplication first and divide it by squaring it. I get the following as an answer. 685.936 and so forth. Well, I'll just include the dots representing it keeps going. So what leaves us with our paraphrase now is FG, don't forget the direction, 686 newtons. Now keep in mind, down, it was 3 sig gigs because all the other values we used, 5.98, 70.0, and 6.38 were 3 significant digits, so we leave it like that. In our paraphrase, now we need to state that. So in that case, we're going to say the force of attraction between the center of the Earth and the student is 686 newtons. I'll just leave the units going in a down direction. Done. If there's any other questions, don't hesitate to let me know. And have a great day.